creating your own image. So far, we've been making use of images that other people built, but of course, as a developer, you often will want to build your own image. It's not super useful to just use pre-built images. Images are created with Docker files. You can think of a Docker file as sort of like a script. It's a recipe for constructing an image. It's very similar to the idea of writing a script, but it's got a much more constrained and limited language, which there are good reasons for, and we'll get into that in a minute. But an important thing to note about images is you can build them locally from source if you have the Docker file, or you can pull them from a remote registry. In your case, when you're doing application development, you will likely want to build locally from source while you're testing, and then once you have a build, you will push your source code up to Jenkins or whatever your CI stack is. It will then build an image from source and push it to Artifactory or whatever repository you're using. And then when you schedule it to run on OpenShift, OpenShift will pull it down and execute it locally. Let's build something fun. If you haven't heard of the game 2048 before, it is kind of a cool little number game that is sort of fun to play. So the game 2048 kind of looks like this. You get a board, and the board has tiles on it, has numbers. This is a more typical one with a 4x4. And the goal is to join these tiles together until you expose a tile that has the value 2048. Each time you combine two tiles, they have to have the same number, and they will combine and add together. So for example, these twos right here, you could join these together, and these would combine to a 4. Then you can combine the two 4s into an 8, and etc., etc. So it's a very fun, addictive game. And somebody wrote a command line version of it. So this is what the command line version looks like as you're playing it. It's kind of rough graphics as you'd expect, but you can see we're combining the tiles. The only controls here are the arrow keys or Q to quit. So it's very simple to play and very fun. This was put together by somebody on the internet, and it was implemented in C, and it's just a single C file, which is very, very neat. So if we follow this link, we'll see here it's up on GitHub, and there's a nice screenshot, and it's got very simple build instructions. So for example, if you want to build it locally, you can just wget the file straight off of GitHub, run it through GCC, and then execute the binary, which is very, very simple. And that makes it ideal for an example to build into an image. The other thing that's nice is that, I don't believe this is true anymore, but when this was first made, it only ran on Linux and only on one specific distro. It didn't run very well on anything else. So it was also a great opportunity to showcase containers, because you could build the container and then move it to any system that supported OCI containers, such as Mac and Windows. And you could run essentially this Linux program on unsupported platforms. So let's build this into a Docker file. Okay, to start out, and as you'll see, we are starting from absolutely nothing. So you get to see the whole process from bare repo on up. So let's start by making a directory for ourselves to run. Maybe we'll call it 2048.docker. Actually, that already exists. I have clearly already done this demonstration on this machine, so we'll have to call this something else. Maybe 2048-docker2. Then we'll change into that directory. So as you can see, we have a bare repository here. First thing we need to do is create a Docker file. So let's do that. Our Docker file is totally empty. The first line in almost any Docker file is going to be the from line. From is how you tell it what layer to start with. So if you recall, I explained that Docker was made up of layers, or these images are made up of layers. So we need some starting point. Let's start from my favorite distribution of Linux, Fedora. Fedora 32 just came out a few days ago, so let's start with Fedora as a base. That is all we're doing so far. So let's see. All right, so here's our Docker file. All we have in there is just a from, but that's actually enough. We have a working Docker file. It's not super useful yet, but we can use it. So I'm going to do, now I'm using Podman locally. It works a lot better on Fedora for me, and I prefer the rootless, or not rootless, I mean I do like rootless. I'm not going to use it right now because there's a small issue that I'm dealing with that is totally unrelated to this demonstration, and I don't feel like fixing it right at the moment, so I'm just going to use sudo with Podman. But you could, instead of sudo podman, you can just type docker, and all of these commands should work just fine if you're following along at home, which I highly recommend you do. If you have your computer with you, or if you want to just pause this video, you can follow along with these steps. And doing is the best way to learn. So again, I highly recommend it. So do sudo podman build. We're going to give a -t. The -t is the tag that we're going to slap onto our image. So for now, it doesn't really matter what we put it in. You know, just some sort of an arbitrary tag is fine. I'm just going to call it 2048. And then the last argument here will just be the context. So build context is not something you really need to understand now. The vast majority of the time, it's just going to be the root of your repository. In this case, it is the root. There are implications of this, but we're not going to worry about that right at the moment because we're still at the intro level. So, oops, I fat-fingered. There we go. So I'm going to execute that, and you'll see that Fedora 32 is not already on my system. So it needs to download that from the remote. And it is now done. So we can actually run this guy. So sudo podman run. I'm going to give it the --rm because, again, when this container exits, I don't care about it. It's just scratch space for me right now. So I just want it to be cleaned up for me automatically. -it, I need standard in and standard out hooked up because I'm going to type into bash, which is what I'm about to run. So 2048 is the image name, and that name just came from what we gave it up here. We could have called it anything we wanted to. And the executable I want to run is just bash. I just want a shell prompt. So you can see it drops me into a root shell inside of Podman and lets me go. So this is the starting point for our Docker file over here. So any sort of commands that we were to put here would be executed in this environment over here. Knowing that, we can slowly build. So first thing we need to do is we need to, if we go back to our build instructions here, first thing we need to do is wget this file. So I'm going to copy that command, and let's make some sort of space on our container where we can do some experimenting and do our work. So I'm going to make a directory just root/2048. And I'll change into that directory. You can see there's nothing in here. So I'm going to now run the wget, which I copied and pasted, and let's see what happens. Wget is not found. We have not installed anything into this container yet. So we need to do that. On Fedora, it's DNF. So we're going to do a DNF install wget. And if you're not a Linux person, you might be confused by this right now. It's just downloading all of the repository metadata, which is a list of all the packages available, and then it will install the one that we ask for. So if this is the first time you're running, this might take a moment. And while that's running, we can go back to our Docker file and get our first command in here. So the run command in the Docker file is essentially some shell command that you want to run. So DNF install wget. I am intentionally inserting an error here so that we can see. But now we need to wait for this to install. I think I will just skip us ahead with the magic of editing. Okay, it came up and said, I found the package. Do you want to install it? I do. So I'm going to say yes, and it will download and install it for us. Excellent. Wget is installed. So let's try our wget command again. It has worked. So it went out to GitHub and downloaded that file. If we look here, we can see it's there. We can open it. We cannot open it in Vim because Vim is not installed. But if we wanted to install Vim, we could do so easily. We've already got all the metadata, so it's pretty straightforward here. So with Vim installed now, we can take a look at the code. You can see it is all self-contained. It's a pretty standard C program. The details are not really important. All we need to know is that it's code, it's there, it works. So now we know that we need to make this directory 2048. So I'm copying this into my Docker file so that I don't forget. Then we want to cd into 2048. Now again, if you already know Docker, you're noticing some serious mistakes I'm making here. I'm doing this intentionally so that we can learn. Yeah, be patient. Then we're now in the directory. We want to run our wget, and now we're good. So let's go back to our instructions. And the way to build this file is with GCC. So let's give that a whirl. GCC command not found. Again, we do not have dependencies installed on here, so they need to be installed. So we're going to DNF install GCC, give it a yes, add it to our Docker file, and wait for GCC to finish installing. And we're done. So we'll try running GCC again. And it exited silently, which is good. No news is good news. And there is a binary on our system now. So we can run it with /2048. Sure enough, it is the game. I'm playing the game. Awesome. All right, I'm playing this a little longer than I should. I concede that. Oh, but we've got the 32 tile up now. Okay, that's enough. So we'll quit. We're back to our terminal. Everything's good. So we've got our Docker file. We ran the same commands there. Oh, actually, we need to add this command, which is how we actually ran it, and our GCC command. There. So now our Docker file has everything from our shell session. So I'm going to go ahead and exit. Now, I exited from this container, and if you recall, the --rm flag was there, so this container has now been removed. The container we were using before is gone. You can list containers with Docker PS or Podman PS. By default, it doesn't show you exited containers, but you can add a -a, and you can see the containers there. So it is gone, which is great. That's what we wanted. But now we need to rebuild our image. So the image we were using before was just built like this, podman build -t 2048, and it built the image called 2048, and we want to do that again. So go ahead and run it. You can see it is downloading and installing wget, just like we expected. It's running the DNF. This may take a few seconds. I'm going to skip ahead a little bit. All right, now it's come up and it said, is this okay? I'm going to press Y, but this is not what we want. Something is wrong here because remember, this is going to be building on a server. Is there going to be anybody on the server to press Y for us? No, there absolutely will not. So we need to make a change. DNF install can take a flag -y, which tells it to just assume yes to the questions. We're going to add that. So I've now added it. I'm going to kill that build and start it over. So now you can see it's not going to prompt us for input, which is good. Your Docker file will have to be written in a way that it doesn't require user interaction, otherwise the build will fail. So I'm going to skip ahead just a little bit here so we don't have to sit here and watch this whole thing repeat. Pretty soon we'll have caching, and that will greatly speed things up. Okay, wget is installed successfully, so that's great news. Next up on our list, we're going to make that directory, as you can see on line 4. So that command worked. Then we're going to run a cd into that directory so that we're in that directory. And if you've got experience with this, you're saying, Ben, that did not work. You did not cd into that directory. That's true. I'm going to show that in a second. So now we're installing GCC, which was one of our dependencies. So GCC is installed. That is great. Next up is to run the compilation step. Oh no! Cannot open output file. It's a directory. So something went wrong here. I kind of hinted at what it might be earlier. Before we go into that though, let's do a quick demonstration of the caching. So if you recall, I said that each layer, or each command, each one of these lines where there's a Dockerfile command, that becomes one layer, and each one is stacked on top of the other as a delta. So we don't have to repeat all of the steps that haven't changed. So let's say that instead of installing GCC here, we just want to install Vim. When we run this again, we will not have to repeat these steps 3, 4, 5, and 6 because those did not change. But we will have to repeat steps 8 and 9 because those depend on the earlier version, which did change. So you'll see this time I build and it says using cache. So that's great. And it skips essentially right to installing Vim, which is an awesome thing. And when we go back and optimize our Docker file, you'll see why that caching can be used to get you a lot better performance. But this isn't going to fix our GCC build problem. In fact, we just created a new one. So let's go back to GCC. I undid the Vim change. And let's look at why this failed. We ran cd/2048 right here. But this Docker file is not a shell. This is something that can kind of confuse people when they first start, which is why I intentionally made this mistake. Each one of these commands executes in a totally fresh shell inside of the image. There's no shell session previously. So when we changed working directories, when that shell exited at the end of that run command, that state was lost. So what we need to do is use the Docker equivalent to changing directories. There's a Dockerfile command called workdir, which will set a work directory. So we no longer need the CD. So now let's try rebuilding. Now notice, we're not going to have to repeat lines 3 and 4 because those didn't change, but everything below that will get repeated. So we wget the file again, and now we've got to install GCC again, and then we will attempt our compilation. Hey, it worked! That's great. But it's now launched itself right into this game, the 2048 game. And what's more, we don't have any terminal. So my arrow keys are useless. What we did not want to happen was we didn't want our application to actually execute at build time. What we want is for this container or this image to be ready for execution at any given time. We don't want to actually run it yet. So I'm going to Control-C out of this. Our build technically failed because step 9 is where it stopped because it was waiting for user input. So we know that we don't want this line, but we do need to run this somehow. Before we get to that though, let's get a working build. So I took out line 8. Everything builds from cache, so it's super fast. Now we can actually run our image again. So I'm going to use the same run syntax here. So run --rm-it 2048 bash. So we're just dropping into a shell prompt here. Notice it put us in the directory /2048. That is because we set the workdir up here on line 5 and we never changed it. So it's still in place. But that's great because now we can... Oh, my cursor disappeared. Fun stuff. Now we can see that our binary is indeed there. So we can execute it, 2048, and now it's working fine. So we've got a built binary, which is good, and things are looking good. Oh, this game is addictive. Okay. So we're getting closer to having what we want. What we really need, though, is a different keyword. Instead of run, we want command. So I mentioned earlier that containers or images have default commands that if you don't specify the command you want to run, that's what gets run. The default command should be the one that is most sensical. So in our case, when users are running this image, they want to play the game. So the command we want to run is the /2048. But this is not actually good practice. In Dockerfile, you should use absolute paths when possible. So instead of // we're going to give a full path. So our /2048 is the directory in which our stuff is, and then the name of the binary is -2048 because that's what we put it up here. If we wanted to call this Hulu, we could do that too. But obviously we don't want to get sued. So we're just going to call it 2048. Now our Docker file fixed. Let's build it again. Most of it comes right from cache, which is awesome. We can run this guy, and it dropped us into a bash prompt, which is not what we wanted. Why did it do that? It did that because I have bash. It's wrapping a line here, but we specified that bash was what the command we wanted to run. I'm going to take that away, so that way we use the default command. I'm going to run this guy again, and boom, it's working. So we now have a useful image that we can ship to users. Great! But this Docker file has some issues that are suboptimal. It's not optimized very well for what we want to do. So let's look at some ways we could improve this. Remember that I mentioned that each one of these commands here becomes a single layer. We can take advantage of that to optimize things a little bit. After one of these commands is run, actually before we do that, let me just say our image size does matter. We downloaded, if you recall, when we ran the DNF install, we downloaded all of the package metadata, but we don't need that going forward. So we can use the command dnf clean all to clean it up. But if we run this, the image is still going to contain all of the bulk. In fact, it may actually be worse after we run this dnf clean. If you picture a Git repository, if you have some sort of big binary file in the repository and it gets committed and pushed up, and you then push a commit that removes the file, it doesn't shrink the repository size because that whole file's contents is still in there in the blobs. If you want to get rid of it, you actually have to remove it from history to make it never be there in the first place. We can take advantage of the way Docker does layering to do this. So this syntax is going to look a little bit weird, but I promise as you get more used to it, it won't be so bad. But we can run compound commands here. So after we install wget, before we commit that layer, we will execute this dnf clean all. But there's something else we can do here. We have these two different lines that are installing dependencies. We can combine those into a single line and then clean up afterward. So let's go ahead and do that. Now again, we have to, our cache was busted because we changed a very early line in our Docker file. So we've got to download all that package metadata again and start from scratch. So I'm going to go ahead and skip ahead a little bit here. Okay, our build is done. Let's run the image real quick, make sure we didn't break anything. Looking good. Okay, awesome. There are more optimizations that we can make though. Line 6 is actually totally unnecessary because the workdir command will create the directory if it does not already exist. So we can remove that. So we'll go ahead and do that. And now we can build and run again. And I won't because I promise you it works. But if you don't believe me, you can try it yourself. There is something else going on here though that we can do to improve this. First of all, we, in this case, we're building from source, but our source code is not co-located in the directory with us. Typically, your Docker file should live in the repository that it builds. It is not good practice to do it like this. Now, there are cases where you may do it like this. You know, sometimes it may not make sense, or maybe the person building the Docker file doesn't control the repository and things like that. But generally speaking, always try to co-locate your Docker file with the source code. So how can we do that? Well, I'm going to copy this wget command, and I'm going to run that over here on my host. So now I've got the 2048.c file on the disk. So I've got the source. So now our source and our Docker file are co-located, but we need to update the Docker file to accommodate that. Because right now it's W getting it from GitHub, but we don't want that anymore. We want to copy our file in from our disk. So we're going to use the copy command, if I can type. And the copy command is syntax you kind of expect. It's source and destination. If the destination is a directory, it's best practice to put a slash in the end. Docker will yell at you when you try to build if you don't. It used to not care, but it's getting more strict, and automated builds on Docker Hub actually fail now without that trailing slash, which I learned the hard way, and it was very annoying, so put a trailing slash. So we copy our source in, and then we run GCC on it. Let's kick off another build and make sure that we didn't break this thing. It's going to build from, it's going to use cache for our packages, which is great. Makes our build nice and speedy. Build succeeded. Let's try running it. And it works. Everything's looking good. So we're now following the best practice of building, or of co-locating our source code with our Docker file, which is great. We are almost done optimizing this, but we are running as root. So let's go back and explicitly run a bash shell in our container. We are root here. It is very bad practice for security to run as root in a container. There are namespaces provided by the kernel that will allow root in the container to not be root on the host. But namespaces are not something that actually happens by default. So oftentimes, if you're root in the container, you are actually root on the host. That has some pretty serious implications. So just like you would never run stuff as root on your host, you should not do so in the container either. But we can't just su to some other user because one does not exist. So we need to create one. Dependencies need to be installed before we can change to a non-root user. So let's install the dependencies, and then we'll use the user command to change users. So we'll become the Docker user. And then otherwise, we'll continue on with the build. Let's try and build this, and boom, it fails. It blows up and says, no user not named Docker. That could have been predicted. What we need to do is create a Docker user. So to do that, we will use the user add command, Docker, and we could specify all sorts of things here, but I'm not going to. We'll just try to keep it simple. Build this guy. So far, so good. Everything built properly. Let's run it. Oops, didn't want to run the shell. And there we have it. So we're no longer running as root in the container, which is great. We now have a pretty good solid Docker file here. We're following the best practices, and our Docker file is pretty clean. It's easy to read. We could squeeze a little bit more out of it by getting rid of this layer if we combine up here, but it becomes a lot less readable. And these layers, you know, this user add Docker layer is extremely light. In my opinion, it's not worth it. It's easier to read when it's written like this, but you know, that's a determination that everybody kind of has to make for themselves. So that is building your first Docker file. All right, we just got done building a Docker file for the game 2048, but I wanted to briefly mention pacvim. So pacvim is a clone of Pacman that uses the Vim HJKL arrow keys to help you train your fingers. It's very useful. If you've ever tried to learn VI or Vim, which I highly recommend, I am a Vim user, it is amazing how efficient it can make you. But it does take some getting used to. And for the first week or two, you're going to be miserable and you're not going to be very productive. pacvim really helps you get beyond that curve by helping you train your fingers with the H, J, K, and L, which in my opinion is the hardest part of learning Vim. But this version only ran on a very specific version of Ubuntu or an Alpine. It was very difficult to run on Fedora, but I'm a Fedora user. So I created a Docker file for this, and I pushed it up and ran it. And That's great because not only is it more secure when you're downloading random code from people on the internet and running it locally, it's kind of nice to have the security guarantees of Docker and containers. And it also made it so that the game was now highly portable because, again, those containers run anywhere. So it's very useful. The Docker file that I ended up using looks like this. So in this case, we're using Alpine Linux as the base, and Alpine is just a very, very small Linux, which is great for little apps like this where you care quite a bit about the size. First, we add the dependencies. So APK is the package manager tool. We add these dependencies. And line 11 here is a little patch that I had to put in place to make it build on Alpine, because again, this was written to build only on Ubuntu. But this patch got it building. And then this is a case where this Docker file does not build the source co-located. It does download it from GitHub. So in this case, we're cloning it. And the reason why I did that is that I don't control this repository. So I did send a pull request to the upstream to put this Docker file in there, but I don't remember if it got accepted or not. I'm not sure if it did or not, but this was something that I could do on my own. So I did it. And down here, this is a more production style add user where we give it a specific UID and a group and all that. It's great. And then we run as Docker. And Tini, T-I-N-I, is a little tool that implements an init system, such as like systemd. And I don't want to get too deep into that because it's kind of complex, but suffice it to say, PID1 on a Linux or Unix system is a very special PID. It has certain responsibilities where it receives signals from the kernel, and its job is to distribute those signals to the processes that are running underneath it. Typical applications do not do that handling. They expect the init or the PID1 to do it for them. In Docker, you'll see that the process that runs is actually PID1, which means that it's not going to do the signal handling and the reaping and things that it needs to do properly. Tini is a tiny but valid init system which will handle signals for you, and it does reaping, and it's very, very small. It's not meant to be a typical PID1 that does supervisory details. It's just a very simple one to get the basic signal handling in your container. So very useful. If you want to run pacvim yourself, you could run this command right now. You don't need the you would probably want to run. Here it is. This is the command I was thinking. You can run this, and it'll download it straight from Docker Hub, and you'll have pacvim running locally. All right. Next up is Intro to OCP. I'm going to end the video here, but definitely, if you feel overwhelmed now, try not to worry. This was a lot of material in a very short amount of time, and you're doing great.